How do you map drainage basins accurately in flat terrain? Imagine trying to find the edges of a water catchment area where the land barely rises or falls. It's like trying to spot the outline of a cloud on a clear day. Mapping drainage basins in flat terrain can be tricky because the usual clues like hills and valleys are almost invisible. But don't worry, there are smart ways to do it. First, understanding what a drainage basin is helps. It's an area of land where all water flows toward a common point like a river or lake. The boundary lines, called drainage divides, are usually ridges or high points that separate one basin from another. In flat areas, these divides are very subtle and hard to see on traditional maps. That's why we need better tools. High-resolution digital terrain models are key. These models use detailed elevation data for each tiny pixel, revealing even the smallest slopes. They help us see where water might flow, even if the land looks flat to the eye. Next, we use computer algorithms and geographic information system software. These programs analyze the elevation data to figure out how water would naturally move across the land. They identify flow directions and accumulation points, which tell us where water converges or diverges. This automated process is much more reliable than manual drawing because it considers the subtle topography. Since flat terrain often lacks obvious channels, the algorithms also look at surrounding higher or sloped areas to infer flow paths. This way, they can predict where water is likely to go even if no clear river or stream exists. Manual corrections, like artificially burning rivers into the digital elevation data, are often avoided. Instead, the raw data and algorithms work together to produce consistent results. Sometimes, field surveys or satellite images are used to double-check the boundaries. If there are existing drainage structures like pipes or culverts, these are included in the mapping process because they change how water flows. Using advanced data sources like light detection and ranging data, which provides extremely accurate elevation measurements, can improve the map's precision. Combining this with existing topographic maps, aerial photos, and surveys helps refine the boundaries further. Analyzing flow directions involves looking at contour lines, which show elevation changes. In flat terrain, these lines are very close together or nearly parallel, so the algorithms analyze their orientation to determine the most likely flow paths. All these methods come together to create a detailed, reliable map of drainage basins. This is essential for managing water resources, planning flood defenses, and understanding ecosystems. In short, mapping drainage basins in flat terrain depends on high-quality elevation data, smart computer algorithms, and sometimes field or remote sensing data to confirm the boundaries. This approach overcomes the challenge of minimal slopes and provides clear, accurate watershed maps.